This video is on key features of a function. This is example 3 with context. Automobile industries must accurately report every vehicle's fuel efficiency. Customers compare the amount of gasoline a vehicle uses per mile it has driven. The graph below displays the amount of gasoline in the tank of a particular vehicle based on the number of miles driven. So we want to identify the independent and dependent variables first. Independent, dependent. So our variables we have is the amount of gasoline in the tank and the number of miles driven. And we can look at the graph as well and see that the miles driven is on the x-axis and the gallons in tank is on the y-axis. So the independent variable is a variable that changes the other variable. Dependent means it depends on the independent. So the dependent happens because of the independent. So if we think about this, does the miles driven depend on how many gallons are in the tank? Or would it be that the gallons in the tank depend on how many miles have been driven? So kind of think of it as both of those kind of make sense. So would the miles driven change because the gallons in the tank decrease? Or would the gallons in the tank decrease because you are driving more miles? So you are driving, the gallons decrease because you are driving more miles. So inherently, the miles driven is going to be the independent variable. And looking at the graph itself, since the miles driven is on the x-axis, that is going to be your independent variable. So miles driven is your independent, and your dependent will be the gallons in the tank. So now let's answer some questions. How many miles have you driven if you have 8 gallons of gasoline left in the tank? So we said we have 8 gallons of gas. So 8 gallons of gas is your Y. You're told Y. We need to know how many miles you've driven. So that means that we don't know the X when Y is equal to 8. So I'm going to use a blue highlighter to find this. So I want, when the Y is equal to 8, I need to know what the X value is. So I'm going to go to the Y-axis, the gallons in the tank, up to the 8. And I'm going to go over to the graph, to the function. I've intercepted the function. Now I'm going to figure out where it hits on the x-axis. And it hits at about 175. So our answer to that will be 175 miles. Next it says, how many gallons of gasoline do you have left if you have driven 125 miles? So this time, the 125 is miles you've driven, so you have the X. How many gallons of gas means we don't know the Y. So we want to know what is Y when X is equal to 125. So I'm going to use a green highlighter for this. Just use different colors to show different things. So I'm going to go to the x-axis of 125. So here's the x-axis of 125. I'm going to go up until I get to the function. I have now intercepted the function. Now I'm going to go over to the y-axis so I can see where it hits. And it looks like it has hit at 10. So then my value would be, how many gallons of gas do we have left? We would have 10 gallons of gas. So again, I used a green highlighter to find where the X was 125, and we went to the Y value where it intersected the graph. The next question says, find the y-intercept and interpret the meaning of this in context of the problem. So the y-intercept, again, is always where the graph crosses the y-axis or when the X value is 0. So we have our x-axis of 0, or the X value of 0. Where does it cross the function? Where it crosses the y-axis. So at that point at 0,15. So our y-intercept is at 0,15. 15. Let me write that in red since that is an answer. Now it does say interpret the meaning of this in context. As a reminder, the context is the amount of gas in the tank after driving so many miles. So the X is the miles driven, the 15 is the gas. This means that I have driven no miles, but I have 15 gallons of gas. So before I even drive, I have 15 gallons of gas. So I would say before the vehicle is driven, it has 15 gallons. Now, with this, so 15 gallons of gas, we could also say that since the car or the vehicle hasn't been driven at all, that means that the tank can actually only hold 15 gallons because that's the maximum that it can hold. It doesn't mean that, this could be a problem where it has been driven or they just didn't fill it up, but generally we can say that this will be a full tank. So we can say that the vehicle can hold 15 gallons. And that's actually very helpful for us because we know that a vehicle can drive and not stop, but it will have to stop eventually because it will run out of gas. Now we would have to stop and get more gas. So we can think about it cannot go further than a specific value. So it will not drive indefinitely. So it will not go on forever. But we also know that the miles driven cannot be negative. We also cannot have negative gallons of gas. So our numbers, we know that they have to be positive because there's no way we can have negative miles or negative gallons. We also know that it has to start and stop somewhere because our tank cannot hold more than 15 gallons, and it also has to stop when it runs out of gas. So that can help us see it later. So E asks us, although not shown, estimate the x-intercept and explain its meaning in context. So the x-intercept is when the y value is 0 or when it crosses the x-axis. So if we are utilizing this graph, we could extend this. I'm just going to draw this and then erase it. We could extend this and say it'll cross down here. Now we don't know where that actual value is. So we're going to estimate using the information here. We're going to estimate where this happens. So we can see that every gallon of gas that it loses, it has driven 25 miles. So every 25 miles, it takes a gallon of gas. So when we're here at 175 miles, and then it does a gallon of gas, it goes to 200 miles. So a gallon of gas, we're at 6, it would go to 225. Another gallon would go to 250. Another gallon would go to 275. Another gallon would go to 300. Another gallon, 325. Another gallon, 350. And the last gallon would go to 375. So I can do that with steps and see that every 25 miles, it is decreasing by gallons of gas, by 1 gallon of gas. So the x-intercept, I would say, would be at 375, 0. So I'm going to write that down here. Since it is when y is 0, it's 375, 0. Now this is approximately because we're hoping that it is that every 25 miles it uses 1 gallon of gas, but we know that cars can be slightly different. So we're going to explain its meaning. Again, this is 375 miles are driven, and we have 0 gallons of gas. So what does that mean? When the vehicle has driven 375 miles, there will be 0 gallons of gas in the tank. So that means that really, before it has to stop for more gas, it can drive 375 miles on one tank of gas. So I'm going to write that. The vehicle can go 375 miles on one tank of gas before it breaks down and you have to fill it up with more gas. Okay, so the next questions are asking for the domain and the range and the interval of the domain over which the gallons of gasoline are increasing and decreasing. So if we look at our graph, we're going to look at our domain and range. Domain are the x values and the range is the y value of the function graph scenario. So remember that this graph does have a scenario attached with it. And we know that the gallons of gas cannot have negative gallons of gas. We also cannot go above 15 gallons of gas. The car cannot go into the negative miles driven. But we also know, which we just found, that the car will only be able to go 375 miles before it runs out of gas. So that's going to help us with the domain and range because these are all of the values that work for the function. So the domain are the x values, which are your miles driven. So we know that the miles, since they can't be negative, they do start. And because we know that if the car runs out of gas, then the car will stop. So we know that the miles start and stop. So we're going to have two numbers for that. Same thing for the range. The range means that we're going to have, it's your gas. It cannot have negative amount of gas, but it can have zero gas, or it can hold up to 15 gallons. So we know that the gas, or the gallons of gas, will also start at a specific number and will have to stop because it can only hold so much. So let's think about this again with this scenario. The domain is your x's. So for the miles, the smallest amount of miles that the car can drive would be 0 miles because it does not have to be driven. So I'll put that as my first number because that's the smallest. Now, the largest amount that the car can drive is 375 because, again, we're not stopping and filling up with gas. We want to see how far it can go with one tank. So 375 miles was what we found was the furthest it will go before we have to get more gas. So 375 would be your largest miles. So I know that all of the miles are going to be between 0 and 375. So I know 0 is less than, and it can be driven at 0 miles, so it will be less than or equal to. And then our miles are also less than 375, but we can drive 375 miles and just run out of gas. So we'll put that less than or equal to. For the range, same scenario, but we're using the y values, which are your gallons of gas. So the smallest amount of gas that the vehicle can hold will obviously be 0 gallons. But the most amount of gas that the vehicle will hold will be that 15 gallons. So we know that the car can only hold between 0 and 15. So we know that 0 is the smallest, so it's going to be less than. But since it can hold 0, it can run out of gas. We'll put 0 is less than or equal to y. And then y is going to be smaller than 15, but it can hold exactly 15. So we'll put that equal to 15 as well. So this is our range because that's the amount of gas that the scenario can hold. Now I can also see that in the graph, there is an arrow here because it will continue to go down on the graph, but it will stop at the x-axis. And we know that because the scenario makes sense for it to stop. But we can also find the domain and range because of the scenario itself. We don't have to look at the graph. On the next one, it says find the interval of the domain over which the graph is the gallons of gasoline are increasing or decreasing. Okay? So if we come up to the graph, we want to know as we trace it, will the graph go up or down? So as I start here at the y-intercept, the furthest thing on the left, as I trace it, what is happening to the graph. So the graph is going down, so it is decreasing, and it is decreasing, and it is decreasing. But will it ever increase? Well, as we drive, the gallons of gas that we have keeps going down until it stops. We don't have the information that we're going to add more gas to it. So that means that our graph is clearly always going to go down because the gallons of gas will always decrease because we're driving the car. So it actually never increases because it never turns as well. So we're going to put never increasing because the gallons of gas never get more. We never add gas to it. The gallons of gas are always going to, it's going to start with the amount that we have and it will decrease. So when I write this, I would have out, I'm going to put it off to the side here, X, actually I'm going to put the X in the middle here. When does it start decreasing? It will start decreasing, so at 0, that's where it starts at. Remember, it's between 0 and 375 is our domain. So we want to use 0 to 375. So 0 is our smallest number, and then it stops. It'll stop decreasing at 375 miles because it has now run out of gas. So we're going to put 0 is smaller than X. It's not equal to because it's not decreasing yet because it's just stationary. And then we're going to put X is less than 375. Again, because it's no longer decreasing, it's just stopped. It has no gas at all. So our decreasing is from 0 to 375.